Here is the question this paper is really asking. When Zolpidem causes next morning impairment, is the story simply women clear it slower? Or is that too blunt? This 2026 paper in CPT Pharmacometrics and Systems Pharmacology looked at 30 healthy Korean volunteers, 15 men and 15 women, after a single 10 milligram dose of Zolpidem. They measured plasma Zolpidem concentrations, then connected those concentrations to 3 central nervous system readouts: DSST, which is a cognitive speed and attention task, CRT, which is choice reaction time, and VAS, which is subjective sedation. The model was fairly classic pharmacometrics: one-compartment PK, transit absorption, first-order elimination, then sigmoid Emax-style pharmacodynamic models. But the punchline is not, look, a model exists. The punchline is where the variability showed up. In the final PK model, no clinically meaningful covariates were retained. Sex was not retained as a final PK covariate in this dataset. That does not prove sex differences are fake. The paper is careful here. The study is small, and prior data still show women can have higher exposure. But in this analysis, the stronger signal emerged downstream, in pharmacodynamics. For DSST and CRT, the model found that body weight, albumin, age, and baseline performance helped explain why people responded differently. Higher body weight was associated with lower IC50 for DSST and lower EC50 for CRT. In plain English, in this dataset, higher body weight lined up with greater apparent pharmacodynamic potency, which is not the lazy assumption most of us would make. Lower albumin was also linked to stronger objective CNS effects. That makes mechanistic sense because Zolpidem is highly protein-bound, so albumin can matter for how much unbound drug is available to reach the brain. Age showed up differently. Older participants had lower baseline DSST and CRT performance, so age may not only change drug exposure, it may change the starting line. And the most useful clinical idea is the split between subjective and objective impairment. VAS, the how sedated do you feel measure, appeared more sensitive than DSST or CRT, so someone may feel sedated before the objective tasks clearly show impairment. That matters because driving, machinery, and early morning decisions do not care whether the impairment is subjectively obvious. My take? This paper is not a reason to rewrite Zolpidem dosing rules from 30 healthy volunteers. Please do not turn one model into a prescribing policy. That would be pharmacometric karaoke. But it is a very good reminder that male versus female may be a practical label, not the full biology. For CNS drugs, risk may live in a bundle: exposure, protein binding, age, baseline cognitive and psychomotor reserve, and what the person actually needs to do the next morning. The useful takeaway is this: personalized pharmacology is not just asking what dose did they take, it's asking what system did that dose land in.